Good morning students. Now I will explain why increased ventilation occurs at basal part of lung. The lung and the chest wall, they move together during respiration. So their respective volume change is equal. So from this picture we can see that the chest wall is expanding. It is moving outward so that the anteroposterior, lateral, transverse and the vertical diameter of the chest wall, it increases. At the same time, there will be elastic recoiling of the lung. So when the chest wall is expanding, the lung will undergo elastic recoiling. So they will move together but in opposite direction. Now the pressure changes across the lung and the chest wall. It is defined as the transmural pressure. The transmural pressure across the lung, it is also known as transpulmonary pressure or trans-lung pressure. How can we express it? Transpulmonary pressure or trans-lung pressure, it is nothing but the difference between the pressure inside the lung and pressure outside the lung. As inside the lung there are alveoli, so PL or the transmural pressure across lung or transpulmonary pressure is equal to PA means alveolar pressure, that is pressure inside the lung, minus PPL means the intrapleural pressure, that is the pressure outside the lung. Now lung volume increases with increasing transpulmonary pressure or positive transpulmonary pressure. So what is the function of this transpulmonary pressure? This pressure is the distending pressure of lung. It acts against the elastic recoiling of lung. So by the elastic recoiling, the lung will try to collapse. This transpulmonary pressure, it will try to prevent this collapsing and it will try to distend the lung. We can prove it mathematically too. So from the previous equation we knew that transpulmonary pressure is equal to alveolar pressure PA minus intrapleural pressure PL. Now alveolar pressure is the sum of pleural pressure and the elastic recoiling pressure. So we can rewrite this, the PA, the alveolar pressure is equal to PPL or the intrapleural pressure plus the elastic recoiling of the lung, elastic recoil pressure of the lung. So now if we replace this value of PA into this equation, we will see that PL is equal to P elastic plus intrapleural pressure minus intrapleural pressure. So as a result of that, we get what? We get this result, that is transpulmonary pressure is just equal to the elastic recoiling of the lung. That means it actually tries to prevent the recoiling and distends the lung. Now we want to see the transpulmonary pressure at the base of the lung and at the apex of the lung. So from this picture it is clear that at the base of the lung, due to the lung weight, intrapleural pressure, it is minus 2.5 centimeter. It is less negative as compared to the intrapleural pressure at the apex, where it is minus 10 centimeter of water. So at the base, the intrapleural or the transpulmonary pressure is minus 2.5 centimeter of water, whereas at the apex it is minus 10 centimeter of water. Now, when the lung has expired the whole air, when the lung is at its resting volume or FRC or functional residual capacity, this PL or transpulmonary pressure at the base and apex will be like this. At this FRC, the alveolar pressure is 0. So we can write the equation in this way. transpulmonary pressure is equal to 0, that is the alveolar pressure, minus 10 centimeter of water at the apex. So we get plus 10 centimeter of water pressure at the apex of the lung. Whereas at the base, the transpulmonary pressure becomes 0 minus 2.5, that is equal to plus 2.5 centimeter of water. So from this, it is clear that the distending pressure, it is plus 10 centimeter or greater of water at the apex, whereas it is minus 2.5 centimeter of water at the base. So we all know that transpulmonary pressure is a distending pressure. So as it is greater in amount in the apex, we can expect that the apical alveoli will be overinflated and the alveoli at the base will be relatively underinflated. Obviously, the distending pressure is plus 10 centimeter of water at the apex. So the apical alveoli is more distended before we start inspiration, and the basal alveoli will be less distended. Now we can see that the base of the lung, as it is underinflated at A4C, it lies at the steeper portion of the pressure volume curve. At the steeper portion of the pressure volume curve. So we can see that the pressure volume curve, it shows the static compliance of the lung, that is the change of volume of lung per unit change of pressure. As the volume is less, so we can expect that it will, with unit change of pressure, the volume change will be much more higher at the base. But as it is already overinflated, this apical alveoli will be almost at the plateau phase of this pressure volume curve. That means increase in pressure, that will not increase much of the volume of the alveoli. So that we can say the underinflated alveoli at A4C at the base will have more stretchability, more static compliance, more change of volume per unit change of pressure in relation to the, as compared with the apical alveoli. This explains why increased ventilation occurs at the basal part of the lung. Thank you and subscribe.